All right, folks, this is Learn Check number 11, corrections. We're looking at right triangle theorems. Let's get into it. So number 1, your family planted a new tree in the backyard. To help it grow vertically, a wire is attached to the top of the tree and attached to the ground. So let's go ahead and start drawing our picture here. All right, tree. Yay. All right, so that's the vertical part, and then it says a wire is attached to the top of the tree to the ground. So obviously this is the ground, this is our wire, and this is our tree. Okay, attached to the ground 13 feet from the base of the tree. So here's our wire, it's attached to the ground, and then it's talking about the base of the tree. So that means the 13 goes here along the ground. If the wire is 15 feet, so this wire is 15 feet, how tall is the tree? And then obviously our answer has to be as a simplified radical. So if we want to know the height of the tree, then that means we're going to put an X over here. Now notice for this problem, we're dealing with sides, and the tree to the ground would hopefully be like our right angle. So that means this is our like hypotenuse. Now, some of us might want to use trig ratios. We cannot use trig ratios because there is no theta in this situation. There is no angle of elevation, there's no angle of depression, so I cannot use trig ratios. So the only other option we have other than trig ratios for right triangles specifically is Pythagorean theorem. So hopefully you knew that this was Pythagorean theorem. So a squared plus b squared is equal to c squared. And hopefully you know that your hypotenuse has to be c. So 15 squared is equal to, these are our legs, and that's our a and our b. It doesn't really matter their order, so x squared plus 13 squared. So obviously we need to simplify this. So x squared is still just x squared. And 13 squared is 169. And 15 squared is 225. All right, we need to get x squared by itself. So let's go ahead and get rid of this 169. So minus 169 minus 169. X squared is equal to, 225 minus 169. So that would be 56. All right, how do we get rid of this square right here? How do we get rid of that square? So remember, to undo a square, we're going to be doing a square root. And what we do on one side, we got to do to the other. Technically, there's an index here of a 2 written in between the little arm of the radical. When the index and the exponent match, they are inverses of each other, so they will kind of cancel each other out. So that means x is equal to the square root of 56. Now, right here, we need to simplify this radical, and it needs to be left as a radical. So that means we need to take square root of 56 and break this down. Now 6 is an even number, so we know we can divide by 2, so it's going to be 25, 26, 27, 28. I'm going to circle 2 because it's prime. We can break down 28. Again, we can divide by 2, and that would be 14. Again, we can divide by 2, and that's going to be 2 and 7. So if we remember, 2 times 2 times 2 times 7. Again, this is a square root, so I'm looking for groups of 2. I have 2 2's. Remember, 2 times 2 would be 4, and we know that the square root of 4 is 2. So that's why we can cross out this group of 2's. One of them is going to be written on the outside. Notice that there's not another 2 for this 2, and there's not another 7 for the 7. So that means when we simplify this, this is going to be 2 times the square root of 14. So this is the height of the tree. And we can see that that's the answer choice right there. All right, number 2. What is the perimeter of, oh, it looks like a typo here. What is the perimeter of the perimeter? What is the perimeter of the triangle once x is solved for? Okay, so looking at this, again, we should see no theta. So that means it can't be trig ratios. It has to be Pythagorean theorem. Our a squared plus b squared is equal to c squared. And again, we definitely need to make sure that we are placing our measurements in the correct spot. This is my right angle, so that means 10 should be my hypotenuse. This is my leg, and this is our other leg. So A and B, it does not matter because those are our legs. C has to be 10 though. Now be careful. When we go to square, we're going to need to do x minus 2 squared plus, and then this x is also going to be squared. So set this up, x minus 2, x minus 2. So we're going to do x squared minus 2x minus 2x, and then 4. So that means we're going to have x squared minus 4x plus 4 plus x squared is equal to, and 10 squared is going to be 100. Now we should notice these x squares here. Remember, if we have x squares, that means we have a quadratic. So let's go ahead and simplify this and see if we need to put this in standard form. So we know that x squared plus x squared is going to be 2x squared, still minus 4x, still plus 4, and this is equal to 100. I still have a quadratic here, even though I simplified this, so that means I do need to go ahead and put this in standard form. So we just need to set this equal to 0, so subtract 100 and subtract 100. So that means we get 2x squared minus 4x. This would be negative 96 is equal to 0. All right, so we have this quadratic. Now we need to solve for x. So you could either use factoring or you could technically use quadratic formula. I personally suggest factoring. I think it's quicker and easier to do. So let's start to factor. So if we have 2x squared minus 4x minus 96 is equal to 0, I'm going to look first for a GCF. Notice I can divide everything by 2. So that means 2 is our GCF. We won't always have a GCF, but when we do, it's helpful. So let's divide by 2, so x squared minus 2x minus, that would be 45, and then 3 from the 6, so minus 48. And again, this is technically still equal to 0. I need my GCF later, so now if I'm going to be factoring this, I need to get my a, b, and c instead of x method. So our a is 1, our b is negative 2, and our c is negative 48. I will say that we're lucky that a is equal to 1 because hopefully you know the shortcut using your side numbers. Let's go ahead and get this set up. 1 times negative 48 is negative 48, and negative 2 at the bottom. All right, side numbers here. We might have to do a little bit of playing around, but eventually we're going to get to 6 and 8. Now remember that when we multiply, it needs to be a negative 48, so I know that one of these needs to be negative. When I add them together, it should be a negative 2. So I definitely want to make 8 a negative, so that way when I add these, I have a negative number left over. Now remember our shortcut. This only works when a is 1. If a is 1, I can go ahead and put my GCF in front. I can set up my parentheses with x and x, and then I can take my numbers that are my side numbers that would have normally been my b terms, and I can put them straight into my parentheses. And again, that only works if your a is equal to 1. All right, so this is our factored form. Remember to go from factors to solutions, or our x-intercepts. We're going to take each factor and set each factor equal to 0. And then from here, we're going to solve for x. Now, our GCF did not include an x, so we actually don't need this. But over here, subtract 6, subtract 6. Notice because we're getting x by itself, and because I have to move this other number, it's always going to be the opposite sign of what the factor was. So our solution is x is equal to negative 6. For the other one, this factor had x minus 8, so I know I'm going to be adding 8. And this solution is x is equal to positive 8. Now let's go ahead and we've got these two answers. Let's relate it to the triangle. Now, some of us might be like, well, do I use both of the solutions? Well, in this case, no, because one of our legs is just an x, which means one of my legs would just be a negative 6 or a positive 8. Now, I don't know about you, but we cannot measure a distance and have it be a negative number. That just doesn't exist. So that means that we are actually going to be rejecting x is equal to negative 6. I don't like that because, again, I don't want a negative value for x because I can't have a negative distance. So that means we're going to be using x is 8. So let's come back to this idea of getting the perimeter. So I know that this side is 10, x is 8 right here, and then this is going to be 8 minus 2, which is obviously 6. So that means we're going to do 10 plus 6 plus 8. And so that would be 8, 9, 10, 11, 12, 13, 14. And 14 plus 10 is 24. Now, this is the correct answer. Obviously, there was an error in the answer choices. This is exactly why you submit your work for teachers to check. So if you had your work there and proved your answer, then you got this question right. If you had your work but could not get to prove this answer, then you still got this question wrong. All right, so again, that is exactly why you submit your work. Sometimes there's issues with answer choices, but if you had shown your work, then you would have been able to prove this answer and you would have gotten this question correct. All right, problem number 3. So we need to solve for x. Now notice we do have a right triangle, but in this we have an angle, and remember that we call that angle theta. So here's our theta right here. So we need to always start with labeling. So here's our theta. From your theta, that opposite side, so from angle to a side, this is our opposite. We've got the right angle, opposite is our hypotenuse. And then whatever is left over, we call our adjacent side. Now we need to make sure that we're noticing like what's given to us and what we need to solve for. So we're given the opposite, we're given the hypotenuse, we need to solve for this theta. Notice we do not need our adjacent in this problem. So now we need to figure out what to do with this. Well, obviously we can't use Pythagorean theorem because there is a theta, so that means we're using our trig ratios. So some old horse caught another horse, taking oats away is my way of remembering it. So looking through our trig ratios, the only one that has O and H is sine. So we know we're going to be doing sine of theta is equal to O over H. So sine, we don't know what theta is. We can put an x here. I normally just leave the theta symbol. But we do know O is 12.5 and H is 15. Now, if I'm going to be solving for theta, I need to switch this to the inverse. So we should see sine with a little -1, and then 12.5 divided by 15 is equal to theta. At this point, it is calculator time, and we need to pull up Desmos. All right, so if you do your keyboard functions, and you should see sine with a little -1, and then 12.5 divided by 15. And then we need to click our settings and make sure that we are in degrees. So make sure degrees is clicked. And so we can see that our theta, or our angle, is about 56.44 degrees is our theta. And that is answer choice D. All right, let's go on to the next question. All right, number 4. So this one we need to solve for x. Again, we're looking at this right triangle. And again, when we're looking to label it, we should see that we do have a theta. So our theta is this 20-degree angle. Again, let's start labeling. So opposite your theta, O to O, this is your opposite side. Here's my right angle, opposite, that means this side is our hypotenuse. And then whatever is left over is your adjacent. Again, we want to pay attention to what we are given and what we need to solve for. So we're given the opposite, we're given theta, and we need to solve for the adjacent. So that means we do not need our hypotenuse in this problem. So we know we're doing our trig ratios because we got that theta there. So some old horse caught another horse taking oats away. Oops, I did an H. I need an H there, not a T. There we go. Taking oats away. All right, so which of our trig ratios is A and O? Tangent. So we know that we need tangent of theta is equal to O over A. Tangent, this time we know what theta is. Theta is 20, and that's equal to 9 over x. All right, we need to solve for x, but I can't solve for x if it's in the denominator. So remember, we want to get rid of this fraction. So to get rid of the fraction, we're going to multiply by the denominator. So we're going to multiply by x and multiply by x. Now, if I multiplied straight across, this would have been 9x over x. And again, our x's would simplify because one's in the numerator and the other one's in the denominator. So that's why when we multiply by x, we're able to cancel out this x because, again, numerator, denominator, they match. So we're just left with 9. Over here on the trig side, we just kind of want to leave x times the tangent of 20 because we're not allowed to multiply. This represents a side and this represents an angle. So I can't actually multiply these two pieces together. But I need to get x by itself, which means I need to get rid of what it's being multiplied with. So we need to actually now go ahead and divide by tangent of 20. And then what we did to one side, we got to do to the other side. Again, tangent of 20 divided by tangent of 20, these match. So we're left with x is equal to 9 divided by the tangent of 20 degrees. And again, we need Desmos. All right, so 9 divided by, and again, functions, tangent, 20. Again, double check. We did it in the previous problem, so it should still be, but double check that degrees is clicked. So we get x is equal to 24.7. and that would be B right here. All right, last but not least, let's take a look at number 5. Now these problems, lots of times students don't really know like where to start. So let's start by actually looking at these two triangles. We should see this kind of diagonal line, or excuse me, this vertical line right here. And we should see these two triangles. So we have like a small one here. So 57 degrees in X, and this is a right angle. And then we also have this bigger triangle here. This has a 12 here for this side, 49 degrees. All right. Now, some of us might want to start with the smaller triangle because it has the X. This is where I want to solve. But if you notice, I don't have enough information. Yeah, I have 57, which is my theta, but I don't have information about either the opposite or the adjacent, so I can't use this triangle to start. So instead, I'm going to come over to this big triangle. And this is what I'm going to use to get started with this problem. So we do have 49, that's our theta. We know that this opposite side is our opposite. Here's my right angle, so that means this diagonal side is our hypotenuse. And that means 12 is my leftover side, aka my adjacent. Now, normally we're trying to figure out, okay, what information is given to us, what do we need to solve for? Well, we have our adjacent, we have our theta. The question is, what should we solve for? We could either solve for our opposite or solve for our hypotenuse. So the question really is or like the methodology here is, what will help us connect to the other triangle? Now, see in this picture, when the two triangles were together, this line right here connected these two triangles. That means if this side right here is 5, then the other side right here is also 5 because they're literally the same line. They're the same line, so that means they would be congruent to each other if these two triangles were separated. So it would make more sense to solve for the opposite because that line connects to the small triangle. If we solve for hypotenuse, this side doesn't connect to the other triangle, so it can't really help us. So we want to solve for the opposite. We're going to ignore the hypotenuse. So again, we should be asking ourselves, which trig ratio is O and A? At this point, hopefully you know that that is tangent. So we're going to be doing tangent of theta. Our theta is 49, and that's going to be equal to our O, which is, we don't know what that is, so I'm going to go ahead and put an X there, over A, which is 12. Again, my goal is to solve for X. I want to first get rid of this fraction, so I'm going to multiply by the denominator, so times 12 and times 12. At this point, X is by itself, so it is calculator time. So let's grab Desmos. All right, so 12 times functions, tangent, and we're going to be doing 49. Again, double check that you're in degrees. And so we get X is about 13.8. This is going to be needed for us to solve for our actual X. I know we use an X here, but X represented our opposite side. So that means if our opposite is about 13.8, then on this triangle, this side is also 13.8. So now we're ready to solve for the small triangle. So again, we've got 57 here. 57 is our theta. It just so happens that the 13.8 is also the opposite here. Here's my right angle, which means X is our hypotenuse. And we have this leftover side, which is our adjacent. Again, we're looking at what do we need to solve for, what was given to us. We need to solve for X. We were given the theta, and we now know the opposite. So we don't need adjacent. So now let's think which trig ratio is O and H. Well, hopefully you know that that is sine. So sine of 57 is going to be equal to O, which is 13.8, over H, which is our x. Again, our goal is to solve for x, but first we got to get rid of this fraction. So again, our denominator, so we're going to multiply by our denominator. Denominator is x. So that means x times sine of 57 is equal to 13.8. And again, we need to get x by itself. So we are going to get rid of sine of 57 by dividing. And whatever we do to one side, we got to do to the other. So that means x is equal to, and it is calculator time. So let's get Desmos. All right, 13.8 and divide that by sine of 57. And again, make sure that you're in degree mode, which we are. And so we get that x is about 16.45. Let's see if it asks us to round anything. It did not say anything specific about rounding. So I'm just going to do 16.45. And this should be your final answer because this solves for the x of this small triangle. All right, hope that helps. Good luck retesting.